Example 4, symmetry, zeros, and maximum R values. It says use symmetry, zeros, and maximum R values to graph R equals 2 sine 2 theta. Now, if you've been tracking, you might notice that this is going to be a rose because we have a 2 here with a theta. So the shape is a rose. And roses are typically centered without any other number added or anything like that. So it's centered about the origin. But the 2 theta is telling me I have 4 petals. 4 petals because it's even, you double them. Okay, so anytime you have an even number, it's going to be doubled. Since it's sine, it's not going to be polar axis symmetry. Meaning it's not going to have the first petal on the polar axis. It doesn't mean it won't have polar axis symmetry. It's just the first petal won't be in the polar axis. It'll be in the first quadrant. Okay, what else can we determine? We can say the max R value is 2. And since there's 4 petals, there's going to be 4 of these maximums. Now, we do know, since it's sine, that no matter what with symmetry, it's going to have theta equals pi over 2 as symmetry. Now, let's look at the picture and then determine how we got this graph. So as you look, it is, in fact, cut this way, like we said it was, because it's sine. But it's also cut here, so it has polar axis symmetry. And it also is cut through the pole, which is pi over 4. So it also is with the pole. I'm just going to put the pole, which is pi over 4. Okay, so that's our symmetry. Now let's talk about how we get these maximums. Again, what do? We take the max value and we say it's 2. Now let's find out if we had to find out where. Now I know you can look at this picture and see it, but sometimes it's a little trickier. So what I would do is I would take that 2 and I would plug it in over here for R. So I would say that 2 equals 2 sine of 2 theta. First step, divide by 2. Can't divide into the sine, but we can divide that part out. So that goes away, and I'm left with 1 equals sine 2 theta. Now, to break the sine from the 2 theta, I do inverse. So sine inverse of 1 equals 2 theta. So this is saying where in the unit circle will sine equal 1? Well, sine is y. So where on this unit circle will our y value equal 1? Well, it would be at this point up here, which this point is pi over 2. So that means at pi over 2, we have 2 theta. Now I'm going to divide this by 2 to get theta by itself, which means pi over 2 gets cut in half. When you cut pi over 2 in half, you get pi over 4. And so this center point is pi over 4, which I know you could have looked at and figured out, but we got it there. So we have the first one. We have the first max at pi over 4. Now if you ask yourself, how do I find my other maxes? Well, what you would do is this full circle has 2 pi, and we know there's 4 petals, which means 4 maxes. So you take 2 pi, and I divide it by the number of petals, which means you have a max every 2 pi over 4, which is the same thing as pi over 2. We have a new max. So if I add pi over 2 to this, I'll get this next one over here. So I would come over and I would add pi over 2, which I need to get a common denominator, which means I need to multiply top and bottom by 2. So what is pi plus 2 pi? That would be 3 pi. And this is now over 4. To get the next one, so I now have pi over 4. I have 3 pi over 4. To get the next one, I would add another 2 pi. So when I add another, not 2 pi, I'm sorry, pi over 2, which is the same thing as 2 pi over 4. This time I get 5 pi over 4. So this max is at 5 pi over 4. Now I do it one more time. You get this last one, the fourth quadrant, which I'm sure you can already see that it's going to be 7 pi over 4, or if you just remember the tricks from earlier in the year, first quadrant has nothing in the denominator, second is almost 1 whole pi, so it's just a little bit less. This one's a little more than 1 pi, this one's almost 2 pi. Could have got it that way, or you could have just kept adding 2 pi over 4, gives us the 7 pi over 4. So there's the maximums. The zeros will work the same way, but we can actually see in between the zeros, they should occur. Let's check it at 0, pi over 2, they're in between these, the maximums, and you can kind of see over here. Since everything is going straight in the picture, everything's in line, there's no tricks here. We could go through and run them this way. But if you weren't sure, again, what do? Plug in 0 for r. So I would say 0 equals 2 sine 2 theta. We divide it by 2, which doesn't do anything to this. Still stays 0 equals sine 2 theta. You then do the inverse. So now we have sine inverse of 0 equals 2 theta. Where does the y equal 0? Go back to our unit circle. Y is 0 at these two spots here and here has a y value of 0. That's the y-axis. This is the x. So what are these spots? This is pi and 0. So we have two different answers to work with here. We either have that 0 equals 2 theta, or we have pi equals 2 theta. Both of them need to be divided by 2. And I find out that I have 0 and I have pi over 2. Those are my first two. How do I get the others? We just follow the pattern. We already discovered that we needed to add pi over 2 each time. So if I add pi over 2, I get 1 whole pi and add another pi over 2, and that's how you get 3 pi over 2. So after saying all that, let's see if you can determine these. Now, as you go to find the maximums, be careful. They only list the first two quadrants worth. They don't go all the way around.